Welcome back to the DIY electric skateboard series. This is episode 3 of the project. In the first video we calculated the cost of building a cheap electric skateboard, and in the second one we looked at the motor that we received from China. If you missed those, go check them out. The link is in the description. Today we are making the battery pack for our skateboard. I'm going to make a simple 6S battery pack from 6 18650 lithium-ion batteries. Before we begin, let me point out that 18650s are really dangerous. If care is not taken, they can leak, cause fire, and explode. These here are LG HG2 batteries. We need only 6 of these for our pack. They have a voltage range of 3.7 to 4.2 volts with 4 volt nominal voltage, giving us a total of 24 volts for our battery pack. It's got a capacity of 3000 milliampere hour per battery, making it an 18,000 milliampere hour pack. Now that's not exceptional, but it's enough for a budget electric skateboard. Let's take a closer look at these batteries. These are 18650 lithium-ion batteries that are becoming increasingly popular nowadays. They are found in electric skateboards, e-bikes, electric cars, electric power walls, you name it. So I would highly suggest you take time to learn about these batteries because they are really the future of energy storage. In this video we will not have time to go into the details of battery choice or comparison of different types of batteries. Make sure you get your batteries from an authentic source. In the first video I did show that I'm buying batteries from China, but I dropped that plan and went for LG batteries instead because safety first. So if you're buying batteries, go for authentic LG, Samsung, Panasonic or Sony batteries, the big four. And make sure you're getting the real thing and not fake ones because there's a lot of fakes circulating in the market. Also make sure you go for the high discharge rate batteries, anywhere upwards of 15C or 20C. First thing I do when I receive my batteries is inspect the positive and negative terminals for any dents or deformations. Also make sure the body and the ring is intact, and that's very important because this separates the positive and the negative terminal. I also check if they all weigh the same as per the manufacturer's standards, and then I hook them all up to a meter and ensure the voltage is roughly the same in all the batteries. All my batteries were around 3.5 volts with a slight variance, but that is okay. When it comes to battery packs, there are all kinds of configurations you can build batteries depending on how much voltage and current you need out of your pack, starting from 3S all the way up to 12, 13 or even 24S packs. We will be building a simple 6S pack, which means all 6 batteries will be in series. That means the negative of the first battery will connect to the positive of the second, the negative of the second will connect to the positive of the third, and so on, making it one big 24 volt battery. Let's put the batteries together. I use these little battery holders that fit together like Lego pieces and make everything easy, but it's not a requirement. You can even use hot glue if you don't have these. Notice how the batteries are placed in opposing configuration next to each other. This is the schematic. Our connections are going to be the first negative to the second positive to the third negative negative to the fourth negative to the fifth positive, and finally the fifth negative to the sixth positive. The positive of the first battery and the negative of the sixth battery will then be the free leads of the entire battery pack. For connections, I use nickel strips because they are safer than wires and have higher efficiency. Make sure you get good quality strips that can handle high currents. It is recommended to get a spot welder to weld these together to the batteries, but the cost of a spot welder is anywhere upwards of $200, so I'm going to stick to soldering. Perhaps we can make a DIY spot welder on the channel someday. Anyway, soldering can be tricky as the battery surface is not really very sticky, so you might have to use more solder than you would think. Also make sure you don't burn the white plastic divider and short circuit the positive and negative terminals because that could short the battery and cause it to explode. The nickel strip ends should be only touching the terminals and not be too long or too short. Make sure you don't apply heat for too long as that could overheat the batteries. It's best to do this in short bursts. Once done, your pack should look something like this. Now your entire battery pack from the positive terminal of the first battery to the negative terminal of the sixth battery should read anywhere between 20 to 24 volts. If that's the case, it means that you have done a good job making the battery pack and your battery pack is ready to use. Now it's time to put some heat shrink over it. Even some electric tape would do. Finally, we have here a 24-volt battery pack ready to be used. But before that, there is one extremely important thing that we left out, and that is the battery management system. If you have been following me on Instagram, I recently received the 6S battery management system, or BMS, from China. Now, a battery pack needs a BMS to ensure that it is safely charged and safely discharged. So that is what we are going to look at next time. Now, if you enjoyed this video, make sure you give me a thumbs up. And if you're interested in building your own skateboard, make sure you subscribe and follow this series. That's all for today. I will see you next time. Until then, keep fungineering and stay safe.